So this is a video to help explain the helper functions of the simulation and specifically the sync/edge circuit, counter 2, counter 1, and the register 5. So I'm going to start off with the sync and edge because it's probably the most basic one. It just consists of a shift register and a clock input and the sync value. So basically this just gets put in here into the shift register, and this value comes out. So say we write 1 into here, you can see that this edge value goes to 1 because the current second bit of this shift register is 0, and it detects the rising edge of that. So say we do that and we do it again. So now it sees that it's not an edge because even though this is 1, it sees that it's been 1 for a while. So, and this sync is just here to synchronize the input with other inputs. So on to counter 1. So this counter is just used to help take some pressure off of the main FSM and just use counter values to help. So basically it just pulses when VA edge is high or certain values of the state machine. So say VA edge is high and I tick this and it'll keep going, and certain value of the state machine, it will, I believe it's 100, and it will count up, and reset will just reset us to 0, and set, let's see, so when the counter value reaches 100, so I'll just do that real quick. So when the counter value reaches 100, we write 0101 into the counter. Just to, and this is just for looping, so that this would be in like a read state. So on to counter 2, and counter 2 just utilizes phase edge and QT sync to determine whether it counts up or down. And when phase edge is high, QT sync is low and the clock ticks, counts up. If phase edge is high and QT sync is high, then it'll count down. If phase edge, regardless of phase edge and QT sync, if BR is high, it'll load the data into the counter, and that's counter 2. So now we're going to go on to the register file over here, and when everything here is initialized to 0, we have a read enable for word 3, and as inputs it takes the current state from the state machine and the output values of counter 1, also a clock. So as you can see, there's a read enable for word 3 at this state, because in order to get rid of errors that appeared. So when the state is 0, 1, 0, 0, 0, 1, 0, and counter value is 0, 0, 0, 1, we are writing to word 1 the counter value, and as you can see, they all write to their corresponding bits, and when I tick the clock. See how this enables writing to word. Actually, enables writing to word 3. If it's just this, this enables writing to word. This enables writing to word 1, and we'll write counter value into word 1. So we'll do that. See, these are all high, and it writes it accordingly. Tick the clock. State changes. Oh wait, I need that high. So now this is a write enabled to word 2, and let's give it a different counter value. So that gets that, and tick the clock to put into the register, and it's the same process for word 3, just different counter values. So here, see, this will get different counter values according to its different values according to the value of counter 2, and we just need to tick that to store it. And now when we hit the action button again, we go into a read state. So at counter value 0, 1, 0, 1, and state at 0, 1, 1, we're reading from word 3. We also read from word 3 when counter value is when the state machine is at state 101. So I'm dyslexic now. But yeah, 101 and 100. So if we change the value of the counter 1 value, it will read from a different word, and this should read from word 2 and give that, as can be seen right here through the select from the multiplexer, and it'll read from word 2 at 101, 100, 101, and 011. And there's that. And then we change the value, we increment it, and that will read from word 1 and gives it to byte here, and it'll read for 0111, 101, and 100. All give me the same output. And the last one is when it's 1000, and this will read from word 0 for 100, 101, and 011. And that's how this register file works.